In today's lab, we're doing an experiment with static equilibrium. So for static equilibrium, there are two conditions that must be met. One, the sum of the forces must be zero, and two, the sum of the torques must be zero. So we're already familiar with forces. We've done labs with that. If the sum of the forces is zero, there's no acceleration on the object, and the object is either stationary or moving with a constant velocity. A torque is just a force applied some distance away from a pivot point, and it causes the object to want to rotate one direction or another. So if the sum of the torques is zero, then there's no net torque on the object, and the object is not rotating. So the first thing we need to do is prepare the ruler, and this is going to be our lever arm that we apply different torques to. We're going to have a pivot point at the 0 centimeter end, and then we'll have the weight of the ruler acting at the center of mass, so that'll be a clockwise torque. And then some weights from pennies. We're going to attach pennies to this. Those will also be clockwise torques. And then we'll attach the spring balance at the end of it, and that will be a counterclockwise torque. So the first thing we need to do before we attach any of that is measure the length of our ruler. And we can't just use the length on the ruler because it extends past the end markings. So just use your tape measure and measure from one end all the way to the other end. And in my case, it looks like 30.9 centimeters, so that would be 0.309 meters. So I'll just write that down on my paper. And we're going to need that in meters because the units for torque is newtons times meters, and so we need our newtons, and then for length, all the length measurements need to be in meters. Now you need to get the string, so this is a heavy-duty sewing thread, and you'll want something about 30 to 40 centimeters long, and I've already cut mine to length here. And then you tie a loop knot at one end. So you need a loop at one end of the thread, and I've already done that with mine. I know you can't see it on the video, so just do that with yours, and then you'll be ready for this next step. So you're going to take the end that does not have the knot, doesn't have the loop on it, and we're going to tape that to the 30 centimeter end of the ruler. So just get a piece of duct tape about this long and tear it in half. You're only going to need a half-width strip for this. So to start with, just take your tape and place this on the end, on the side that has the markings on it. And then just flip your ruler over and take the thread and place it right here so that you have maybe about 2 inches on the ruler here. So once you tape the tape over this, then you'll still have some sticking out beyond that. So I'm just going to wrap the tape around it like this, and then back around so that it's coming up here again on this side. So I've got it taped just like this, and then it's got it a little bit sticking out past that. So I'm going to take this extra now and fold it back over the tape, and then I'll wrap the tape over that and back up onto the top side. So now I've got the string going in and then wrapping back over, so it's getting taped twice, and that way it's not going to pull out and slip out during the experiment. It'll hold it tightly to that. Now we just need to weigh our ruler, and if you have holes in the ruler like I do on mine, then you can just use your spring balance through one of the holes on that, and if not, then just use the loop at the end of your thread. And make sure before you do this that you zero your spring balance. I've already done that with mine, and since I have the holes on mine, I'm just going to hang it from that. So I'll just put the hook through one of those holes, hang it like this, and then record the mass of my ruler in kilograms. The next thing we need to do is prepare the pennies. And hopefully you've still got these grouped in stacks of 10 from the previous labs, but if you don't, then just make stacks of 10 and wrap Scotch tape around them to make tight bundles like this. And we're going to need 5 to 7 bundles for this lab. Now we need to weigh these. We need to get the mass of each one. So just take a small piece of Scotch tape, and you can kind of just wrap it around so that you can make a sort of like a loop, a holder like that, and then just hang them from the spring balance. So each one of these is probably going to be around 25 grams, but just weigh each one individually, record their masses, or you could even just write it directly on there, write it on the stack. But however you want to do that, just record the mass of each stack so you know what they are, and then we're going to combine these to make larger groups of weight. Then we just need to tape them to the ruler. And there are a couple places where you can't do it. You can't do it at the 0 centimeter end where we have the pivot point, and you can't do it at the 30 centimeter end where we have the spring balance. And you also cannot do it in the center where we have the center of mass of the ruler. But anywhere else you could do it. I would suggest, though, that it would work better if you have them between the center of mass and the 30 centimeter end where we have the spring balance. Having them farther out like that, it's going to potentially reduce your error for the experiment. So we want to have two different groups for these. And if you're doing 7, then I would recommend you have a group with 4 stacks and a group with 3 stacks. And if you're doing 5 or something like that, you could do 2 and 3 or something like that. I'm going to do all 7. So I'm going to have a group of 4 stacks and then a group with 3 stacks. So we're just going to attach these with Scotch tape. And don't worry too much about where you're placing these right now. You'll measure the length later, the position where they're at. But just put one on there, and I'm sure you can figure out different ways to tape these on here. But this is how I'm going to do them. I'm just going to wrap tape around it like that, and then just do that for each stack. Alright, so now this is going to be my group of 3, and I've got 2 on here already, which means then I'm going to flip this over, and I'm just going to tape this bottom one so that it's centered between the 2 like that. Alright, so there's my group of 3, and each of my stacks were 25 grams, so this would be 75 grams, or 0.075 kilograms. And now I need to attach my 4 groups. Alright, so I've got 2 stacks on the top here, and then I'm going to tape 2 underneath on the bottom, right below them. Alright, so I've got these attached, and now we just need to measure our distances. So we have 4 distances for this. We have the distance to the center of mass of the ruler, the distance to mass 1, to mass 2, and then the distance to the spring balance force. So the distance to the spring balance force is just the length of the ruler. You already recorded that. And the distance to the center of mass is half the length of the ruler. So just take your ruler length, divide by 2, and that gives you this one. Now for the 2 masses, mass 1 and mass 2, we need to use our tape measure for this. So I'll just put the end of the tape measure right in the middle there, and then go to the end of the ruler, to the 0 centimeter end, and that is 19.3 centimeters for me, so that would be 0.193 meters. So let me just mark that down. So that distance was x1 from the 0 centimeter end to the center of mass 1. And then we'll do the same thing for mass 2. So we're going to measure from the center of mass 2 to the 0 centimeter end of the ruler. And for me, it looks like 25.1 centimeters. So that would be 0.251 meters. And obviously it'll be different for you. And then I want you to take your paper triangle. So I know it's technically not a triangle, but if you cover up this part is the triangle. And we have a 60-degree angle marked on here, a 30-degree angle marked, and then the angle here between the horizontal and this angled edge is also 30 degrees. So use a protractor and verify that it's actually 30 degrees. Or if it's not 30 degrees, then record that different angle, and that's the angle you'll use for this experiment. So just line this up on here and check to see if it's actually 30 degrees. And it looks like in my case it is 30 degrees, so I'm just going to go ahead and use that angle for the experiment. Then we just need to tape this to the ruler. So we're going to use Scotch tape for this, and you want to get several small pieces. So we're going to put it at the end here and then tape it on both sides, the front and the back, so that it holds it upright like that. So this is going to be used to set the angles for our string. So if it matches up with the angled edge, then that's at the 30 degrees, and if it matches up with the dashed line, then that's at 90 degrees. So I'm just going to go ahead and tape that down to the ruler right now. Okay, so when you finish, it should be able to stand up just like this, and make sure that it's straight, like lined up exactly with the ruler. You don't want it, tilted a little bit one way or another. If it does that, then these angles aren't going to be accurate. So just line it up like this, and that's the last thing we need to do before we set up the pivot point. So just grab a book or some sort of ledge or raised surface, and we'll use another strip of duct tape here to tape the 0 centimeter end of the ruler to the edge of the book. So it needs to be at the very edge so that it can actually pivot at the 0 centimeter end. So just put your tape on the end of the ruler, and then just line up the very edge of the ruler with the book. So just like this. So it's kind of just barely resting on the edge of the book, and then the tape keeps it from falling off. And if when you're doing this it slips down kind of like off the edge of the book, just pull it back up so that it's actually sitting on the book. We want it to actually pivot like this and not just be hanging from the tape. That's it for the setup. Now we just need to collect our data. And we're going to have two different angles. So we're going to attach our spring balance to this loop and then hang it at a 90-degree angle and a 30-degree angle. And that's going to match up with the edge of the triangle here and the dashed line on the paper. We're going to start with the 90-degree angle. We have the loop attached to the spring balance hook, and then you're just going to hang it so that the ruler is level. It's going to be parallel or level with the table, and then the string should be parallel with that dashed line on the paper there. So once you have that all lined up, just read the force in newtons from your spring balance, and in my case it looks like it's about 1.4 newtons. So I'm going to write that down on my paper. This is going to be the 90-degree force, and that is 1.4 newtons. And it'll be different for yours depending on where you placed the masses. Then we'll do the 30-degree force, and for this one you may need to hold the book still. When you're pulling it at an angle like this, then the book is likely to start sliding. So just hold it still with your hand and then stretch the other one out. So again, the ruler needs to be level with the table, and then this time you're going to line up the string with the edge of the triangle there. So you're going to get something like this, and then again you'll just read the force in newtons from your spring balance, and this one is going to be more than the previous one. So in my case it looks like it's about 2.6 newtons, and again that will vary depending on your penny placements. So that's it for the data collection. Now you just need to find your forces and your torques and sum all of those up. So you're going to have your clockwise torques, your counterclockwise torques, and they should be equivalent. So you'll be able to compare that by computing the two and then comparing them to each other. And as always, read your instructions carefully. They will have more information than what is shared in this video. And good luck on your experiment.